The KeyWest case. As we learned, the KeyWest case is a decision analysis that involves three chance events. First, the market size could either be large or small, 300 mil or 200. The share that KeyWest is planning for, 30% or the large share versus 20%, the small share. And then their costs for production are also a chance event with two states of nature, either the high cost at 70% of sales or the low cost at 60% of sales. Because we have three chance events, 2 by 2 by 2 is going to produce 8 payoffs. So I've created a table to help you get started determining those payoffs. So of course we're going to get 4 of each. 2 by 2 by 2 gets us to 8 possible outcomes. For example, the best case scenario would be the large market and the large share, which is going to produce 90 million in sales, simply 300 times 30%. If it were the best case scenario, they would get the low cost. So 60% of sales, 60 times 90 million, 60% times 90 million is 54 million in cost, which makes our payoff simply 90 minus 54, or 36 million per year for the best case scenario. And I've started the table to help you see the other 7 payoffs that you're needing to calculate. Now, we're going to add this information to a decision tree once we're able to calculate the net present value of each of these outcomes. And we'll talk about that in a moment. But let's first look at the decision tree. So I've added to our starter model, this is just our regular starter model, but I've backed it up a step and added this decision node. This is the key decision that KeyWest is trying to make. Should the MES, the new product, be a go or a no-go? So of course, if it's a no-go, the process stops and the payoff would be 0. They just would not go forward with the MES. But if it is a go, then we're looking at our standard 2 by 2 by 2 decision tree. And here I've set up part of this for you. So if we assume the large market, 300 million, we could either get 30% or 20% of the market. If we get the 30%, we could either have to pay the high cost or the low cost. So the one that we just did is the best case scenario. The big market, the big share, and the low cost produces a payoff of 36 million per year. But the NPV of that is what we really need, because remember, KeyWest uses a 16% discount rate for financial planning. And this is going to affect the net present values significantly. So let's look at an example NPV table for the best case scenario and see how that discount rate is affecting our decision analysis. So here is the NPV table that we started. This is a complete example for you. So you would have one of these for all 8 payoffs. We are only looking at the first payoff now, 36 million annually. And this is sometimes called our gross profit, or I have it labeled here before tax profit, because that's the only thing that we're taking away other than our discounting. So remember from our case, straight line depreciation of our $60 million investment. So that's 10 million a year, making our taxable cash for the best case 36 minus 10, or 26 million a year. We were also given in the case that the tax rate is 40%. So quite simply, 26 times 0.4 equals a tax bill of 10.4 annually. Then to get our after tax, our before tax or our gross profit minus our tax gives us our after tax cash flow. So here it's 25.6 million for each of the 6 years. But remember, KeyWest uses that 16% discount rate for financial planning. And this is going to help us determine the time value of money. Remember, futures have to be discounted to make it a present value. So we have a future here. The expectation at the end of year 1 is 25.6 million. Well, 1 year of time, a lot of things can happen. So we're going to use our simple discounting 1 over 1 plus r to the year. Okay, so here 1 over 1 plus 0.16 to the first power gives us our discounted revenue after tax, or what we call the PV, or present value cash, of 22.07. And we can see that if the discount rate were to go up, we would get more discounting. So when the discount rate goes up, the PV values go down and the net present value would go down as well. Back to 16%, back up to 34.33. Now, if the discount rate were smaller, you can see that the NPV is affected significantly. So in the KeyWest case, it's the cash flows that we're using to calculate a single net present value for each of the 8 outcomes. And we're starting with the discount rate of 16%. So this 34.33 million is simply obtained by taking the sum of the PV cash flows and then subtracting our initial investment to get our net present value for the best case scenario. So on our decision tree, the net present values, I've added a cell right next to those cash flows, payoffs. And once you have all 8 NPVs calculated, you should be getting a mean NPV of about 3.1. And so you can check your work that way. Hopefully this has helped you get a good start on the KeyWest case and review the NPV table that we discussed in class, as well as the 2x2 decision tree.